So hello everyone and welcome to today's video. So today I'll be walking through a very exciting and important topic, which is how to evaluate your LangChain and LLMs using BeyondLLM to build a robust Retrieval-Augmented Generation system. Now I know that sounds like a lot, but by the end of this video, you'll not only understand what RAG is, but you will also be able to set up and evaluate your own document retrieval system with cutting-edge tools like LangChain, pairs, Hugging Face models, and of course beyond LLM for the evaluation. Okay, so let's start up our environment. We need to install several packages to get everything up and running. So these are some of the packages we're installing. We have the LangChain, sentence transformers, and we have the Llama CPP, Python, and Rock API, and FAS and everything. So we're going to install all of this. Once you have installed all of this, I would urge you to restart your collab session with Jupyter kernel. This ensures that all the libraries are properly loaded and ready to use. This step can save you a lot of headaches down the line because it avoids any dependency errors. So you go to runtime and you go to your restart session. After you've installed all your necessary packages, after that, it's time to import the libraries we're using. So each of these play a very crucial role here. So we have the PyPDF directory loader and the text splitter for the pre-processing of the documents. We have embeddings and the LLM we're using ChartGraph and pairs for the vector embeddings, and these two for building the track chain. Then at the end, you can see we are importing context relevance, groundedness, and answer relevance from Beyond LLM, which are our evaluation metrics from Beyond LLM framework that we'll be using to assess our RAG system performance today. So once we import these libraries, we can move on to our API keys. Okay, so before we start using the language model, we need to set up our API key. So for this tutorial, we'll be using the Grok API. If you don't already have a Grok API key, you need to sign up for on their website. Okay, so it's crucial to handle API keys securely. We never want to hard code them so that they're always hidden from the public and you don't end up posting it anywhere. So once we're done with that, then go to processing of the documents. So we'll start by loading a PDF. So for this, I am using a data set on heart health. So we load the document here, then text splitter. So we need to text this document into smaller and more manageable chunks. This is important because large documents can be too much for a language model at once. So here we're creating 750 chunks with a chunk overlap of 50 characters between chunks. The overlap helps maintain context between the chunks. You might need to experiment with these values depending on your specific use case. Okay, next we have to create embeddings here. So we're using these embeddings here. So we need to create embeddings for them. Embeddings are dense vector representations of our text that capture semantic meaning. We'll be using a Hugging Face embedding class with the model BAI BGE base version 1.5. This model is particularly good for creating embeddings for English text. So if you go here and print the embeddings, you'll see some information about the model being used. Next, we have the vector store. So we are using FAS here. FAS is Facebook AI Similarity Search. It is a library that allows efficient similarity search and clustering of dense vectors. It's particularly useful for our RAG system as it allows us to quickly find relevant document chunks for given query. So, okay, so now we have loaded our documents, splitted them into chunks, created embeddings for these chunks, and stored them in searchable vector store. So here we have a query which says what causes heart diseases, and we have this search is equal to vector store or similarity search. Let's perform the similarity search in our vector store for a query, which is what causes heart diseases. So the similarity search method returns a list of most similar documents to the query. So we can set up the retriever here. We're creating the retriever with our vector store here. The search box gave values set to 3 parameter, telling the retriever to return top 3 most relevant documents for each query. So we can print the top 3 most relevant ones here, just to get an idea about that. Next, we're going to initialize a large language model. So with the retriever setup, the next step is to initialize a language model. For this tutorial, we'll be using Grok API to assess a powerful language model. So we're using the Llama 38B8192 here, and we have set the temperature to 0.1 to get like more control on the randomness of the model's output. The lower the temperature, like zero point 0.1, makes the output more deterministic, which is more desirable for the question and answering tasks. So this language model will be the core of a RAG system, generating responses based on the context provided by a retriever. The next step is to define the RAG chain here. So now that we have a retriever and language model set up, we can define a RAG chain. This chain will tie together all the components we have set up so far. This is a prompt template. Template sets up an AI assistant's behavior. It instructs the model to follow the instructions well, be truthful, and give direct answers. The query placeholder will be filled with the user's query. So next we'll find the RAG chain. So in the RAG chain, you can see that the context is the retriever. This sets up the inputs for a chain. Okay, so the retriever will fetch the relevant documents, and the runnable pass-through allows the original query to be passed through. And prompt, this pipes the retrieved context and query into a prompt template. Next, we have the LLM, which sends the filled prompt to our language model, and then we have string output parser. This ensures that the output of our language model is passed as a string. So this chain efficiently combines all our retrieval system with our language models, allowing us to generate answers based on both the user's query and the relevant information. So we also have two functions here to extract the number of responses and one to tokenize sentences. This will further be used in our evaluation. So now let's start with the evaluation. So now that we have a RAG system set up, it's time to focus on evaluation. So we'll use three key metrics from the BeyondLLM framework to assess the quality of our system's outputs. First, we have context relevancy, then we have answer relevancy, and we have groundedness. So what we're going to do now is, what this function does is, it iterates through each piece of retrieved context, uses our LLM to score the relevance of each context piece to the query, and then extracts the numerical score from the LLM's response, and then calculates and returns the average relevance score. This is what a context relevancy does. Next, what our answer relevancy does is, it tells us how well the generated answer addresses the given query. Okay, so this function uses a LLM to score how relevant the generated answer is to the original question. And finally, we have groundedness score, which measures how well the generated answer is supported by the retrieved context. So here is the function for that. And the groundedness function basically splits this response into individual statements. For each statement, it uses an LLM to score how well the statement is supported by the context, and then at the end it calculates the average of the groundedness score. So let's start by running all of these evaluations now that we know what we do. So yes, we get our context relevancy here is 7.0. Next we run this, we get an answer relevancy score, which here it is 9, and here the current score is coming 7.7. So basically, what do you understand from this result? So the score of context relevancy, which is between 0 to 10, indicates how well a retriever is working. A high score means that you're finding documents that are highly relevant to the query. If the score is low, we need to improve our document processing or retrieval method. And then we have the answer relevancy, which tells us how well our generated answer addresses the query. The high score means that our RAG system is producing responses that are on topic and directly answer the question. Okay, next we have the groundedness score. That, like I said, it indicates how well our generated answer is supported by the retrieved context. So a high score determines that our system is producing answers that are firmly grounded in the provided information. So if the score is low, or a system might be hallucinating or generating information that is not present in the context. So remember, these scores are meant to give you a quantitative way to assess and improve our RAG system. Based on these, you can make changes in the prompts, or you can change the large language model. You can experiment with different models and the temperature settings or the splitting. You can change anything with relation to how the scores are coming. Okay, so there you have it, folks. We have built and evaluated a RAG system using LangChain and BeyondLLM. So this RAG system allows us to generate responses that are not only based on the large language model's training, but also on specific relevant information from a document set. So by using evaluation metrics, we can continuously assess and improve the system's performing. So remember, building effective AI systems is an iterative process. Use the evaluation metrics we have discussed to guide our improvements, and always consider the specific needs of your use case. So thank you very much for joining on this journey where we discovered more about track systems and LLM evaluation. I hope you found the tutorial informative and useful. If you have any questions, feel free to leave them below or on Discord channel. Don't forget to like and subscribe. And I'll leave the link for this notebook and also for our GitHub in the description below. See you in the next one. Thank you.